Alright guys, let's go ahead and start today's lesson by simplifying some radicals. So in this first column here, I have a radical 4. And when I simplify that, the square root of 4 is 2. Okay. Then I've got radical 9, which the square root of that is 3. Then I have radical 18. Now with radical 18, there is not a perfect square root to 18, but I do know that I can take radical 9 times radical 2, which is also equal to radical 18. Okay. Then I take the square root of 9 is 3, and since there is not a perfect square to radical 2, I have 3 times radical 2. Same thing for the square root of 27. 27 is not a perfect square value, so we take radical 9 times radical 3, which multiplies to 27. The square root of 9 is 3. There is no perfect square value to radical 3, so we have 3 times radical 3. Okay. 75 is not a perfect square value, so we can break that up to radical 25, which is a perfect square value of 5. And since radical 3 is not a perfect square, we have 5 times radical 3. Okay. This last one is like our literal equations, where we've got the square root of b squared, and we said a square and a square root cancel out. So then we are left with b. Okay. So on my first column, those were all positive radicals. Even though some of them needed to be broken apart into smaller radicals, still they were all positive. Okay. All right, so let's go over to the second column that I have here. I have the square root of negative 4. Okay. So that one there can be broken apart into the square root of 4 times the square root of negative 1. That there is going to reduce to 2, and anytime we see a negative 1 under the radical, we're going to put an I for an imaginary value. Okay. So negative 9, we will have 9 times negative 1. The square root of 9 is 3, and the square root of negative 1 is I. Okay, next one, square root of negative 18. So I get square root of negative 9 times 2. Okay. Still can't have a negative with that 9, so I have the square root of 9 times the square root of negative 1, and then times the square root of 2. That gives me 3. Negative 1 is I, radical 2. Okay, for this next one, negative 27, it can be broken apart into negative 9 times 3. Negative 9 can be broken apart into 9 and negative 1 times radical 3. And that would put us at 3 times I times radical 3. Okay. All right, next one, negative 75 is broken apart into negative 25 times radical 3, which is equal to radical 25 times radical negative 1 times radical 3. The only one that's a perfect square is radical 25, so that gives me 5. Radical negative 1 is I, with radical 3. Okay. This very last one, which is like a literal equation, is the same thing as the square root of b squared times the square root of -1. And a square root and a square cancel out. So I am left with b times I. Okay? So what I want you to see is in this very last column, every time that I had a negative under the radical, all my answers had an I in them. Okay, so whenever I see a negative, I know there's going to be a radical, and it's always going to be following the coefficient that comes out to the outside. The radical part, if there's a radical value that still needs to remain under the radical, that just stays off to the right side. Okay. All right, so let's go look at our notes for today. Okay, anytime that we see an I anywhere in our answers, that means that there was originally a negative underneath the radical sign. Okay. If we ever find I squared, that can be simplified as -1. And let's see. All right, so here's some ways that you could see the answer. Here is 6I. That was originally -36 underneath the radical. -2I. That was originally negative -4. I radical 3. That one there was originally -3 under the radical sign. Okay. All right, so looking forward, anytime we see a negative, we will know that we can take that negative right out. Okay. So if we do break this apart so that we can see it, we have b squared okay, so the square root of b squared is going to be b, because these two cancel out. Oops, that's not an I. Sorry about that, let me erase that. That should have been a -1 there. B squared times -1 gives me a negative b squared. So then I've got b times I. Okay, let's look at A. All right, so here, this is going to be -9 times 3. And like we said, anytime that we see this I or this negative here, we know there's going to be an I on the outside. Okay, so the square root of 9 is 3. Since it's negative, it's I. And we can't have a square root of this radical 3, so that just stays 3I radical 3. Okay, for B, when we're looking at B, you have to know your perfect squares. You kind of got to be able to look at them and say, how can I break that apart? Okay, because 216 is not a perfect square. Because 15 is 225, 14 is 196. So we've got to see how we can break this up. What can this be divided by? All right, so I was looking at this, and if I do 216 divided by 6, I get 36 times 6. Now remember, one of them has to be negative, and I'm going to make that perfect square value negative. 36 is a perfect square, so that gives me 6. There is not a perfect square of radical 6, so that stays. Okay? All right, so let's go on to the commutative and associative properties. Commutative property is when our values can get switched around, and that works with multiplication and addition. So if I said 2 times 3, I would get the same answer as if I said 3 times 2. Associative property just means that they can be grouped together. So if I was doing 2 times 4 times 3, I could either multiply 2 times 4 first or 4 times 3 first, and either way I'd get the same answer. Okay? So if I ever see I to the first power, that is going to equal I. If I see I to the second power, that's going to equal -1. If I see I to the third power, that's going to be -I. And if I see I to the fourth power, that's going to be +1. Okay? And that cycle just repeats. So I to the fifth power would be I to the sixth power would be -1. So like with these 4 values, it's going to just keep repeating over and over and over again. Okay? All right, examples 4.42, products of pure imaginary numbers. So we are going to be multiplying these two, but before we multiply them, we need to simplify any radicals if there are any. Okay? Then we're going to multiply the coefficients, and then simplify the radical if there is any that remain, and then simplify the imaginary values. All right, so let's get started with one of these. So here, I'm going to take the coefficients and I'm going to multiply them. So -5 times 3, that gives me -15. I times I gives me I squared. Okay. Looking up here on our table in the purple, anytime I have I squared, I can replace it with -1. So I'm going to have -15 times -1, which gives me +15. All right, let's look at B. First thing, simplify the radical. So this -6 can be broken up into I, not J, radical 6 times I radical 15. Now I'm going to go ahead and do the coefficients first, or the I values. So I'm going to do I times I. That gives me I squared. Underneath the radical, I have 6 times 15, which is 90. I squared makes -1. All right, so then I have the square root of 9 to the square root of 10. So I have -1 times 3 times radical 10. So my solution on this one is -3 radical 10. Okay. All right, now we're going to go on to 4.43, solving these with imaginary solutions. So in order to solve this, I have to get rid of that +64 by moving it to the other side. So I don't want it on the left side. I want it on the right side. So I'm going to have x squared equals -64. To undo a square, we square root it. Whatever I do to one side, have to do to the other. Okay? A square and a square root cancel out. So then we're left with x equals, that negative comes out as an I. The perfect square value of 64 is 8. So x equals 8I. All right, now we're going to go into some operations with some complex numbers. Again, complex numbers. let me jump up to the top here and go over what a complex number is. Okay. So up here, you guys back in Algebra 1 talked about real numbers. So rational numbers, integers, whole numbers, natural numbers. Now we're bringing into it imaginary numbers when we have a negative underneath the radical. Okay. So we are going to make complex numbers where we have real numbers that are going to be referred to by the variable a, and complex numbers which are going to be referred to by the variable b, followed by an I to represent that there was a negative underneath the radical. Those two pieces are going to be added together to give us our complex formula. A plus BI. Okay? All right. So here, if B were to be 0, okay, so if we have A plus BI, if B were to be 0, 0 times I would just be gone. So that would mean our answer is a real number. There's only A, and A is a real number. If B was some number other than 0, like 4I, for example, it's just a random number I put in, that would be okay. That would be a complex number because we have our real number and we have our complex number. If A equals 0, so if A was 0, it wouldn't be complex because now I no longer have an A value. I only have the imaginary number. Okay. All right, example 4.4.4. We are going to solve or simplify complex numbers. Now here's the thing. I said every complex number has to have an A value and a BI value. Okay. So we have to identify which part is the A and which part is the imaginary. So which part is a real number, which part is the imaginary number. Right? All right, so looking at the left side, remember I said A, this is A, and the B value is always in front of the I. So here's our B, and here's our I. Okay. On the right side of the equation, B is always in front of the I, and the value in front of that would be A. So what I'm going to do is I'm going to take the A portions and I'm going to set them equal to each other, and I'm going to solve for the X. Then I'm going to take the BI portions and set them equal to each other and solve for Y. So I'm going to take 3x plus 5 and set it equal to 7. And I'm going to take y minus 3 and set it equal to 6i. All right, let's solve for x first. So we have 3x equals 12. Nope. 3x equals 2. Divide both sides by 3. So then, divide both sides by 3. So then I get x is equal to 2/3. Okay. Now we've got to find the y value. So I'm going to rewrite this so that the I is not in the equation. I'm just looking at those values. So I have y minus 3 is equal to 6. The I is still here, but it's just off to the side. Okay? So then I have y equals 9i. Okay, So let's go down to adding and subtracting complex numbers. When we are adding, it's like combining like terms. So we are taking 5 plus 2, and then we're taking negative 7i plus positive 4i. So 5 plus 2 gives us 7. Negative 7i plus 4i is negative 3i. All right, now on this next one, when we're talking about subtracting, is similar to adding the opposite, okay? And we've talked about it in class. We can take this negative and distribute it to both of these, or you can just see it as adding the opposite. And some of you said, well, we can change this to a positive, this one to a negative, and this one to a positive. Whichever way you decide to do it, just make sure that you are consistent with it, okay? So taking our coefficients, so we're going to have 4 minus 3. That gives us 1. And then you're going to have negative 8 minus negative 6i. So that gives us negative 8 plus 6i. All right. So I have 1 plus 2i. Okay. Nope. Hold on. Mistake on that one. 4 minus 3 is 1. Negative 8i plus 6i is negative 2i. Okay. All right. Last one that we are doing together is multiplying complex numbers. So this is where we did distribution. This is where we said we were going to take 2 times 9 minus 3i. And then we would do positive 4i times 9 minus 3i. Let's see, so 2 times 9 is 18. 2 times negative 3i. Four I times negative 3i is negative 12, and that's I squared. I times I is I squared. Combine like terms, so I've got 18 negative 6i plus 36i gives us positive 30i, and then negative 12. 1 squared is negative 1. Okay. Oops. So we have 18 plus, and keep that 30i there. Negative 12 times negative 1 gives me positive 12. 18 plus 12. Okay, we get 40. 30. My goodness. 30 plus 30i. All right, so your independent practice today is to complete examples 1 through 9 and make sure that you upload that to Canvas.